Every time you board an airplane, thousands of gallons of fuel are sitting inside its wings. Yet the fuel powering that giant machine isn't gasoline. That sounds strange when you think about it. Gasoline powers sports cars, motorcycles, and race cars, so surely an airplane carrying hundreds of passengers across oceans would use the same fuel. After all, jet engines are far more powerful than car engines, but they don't. Instead, modern airliners rely on kerosene, a fuel most people associate with old lanterns and camping stoves. At first glance, that choice makes almost no sense. Why would one of the most advanced machines ever built depend on a fuel that seems so old-fashioned? Is kerosene more powerful than gasoline, or is there a hidden reason most passengers never hear about? To understand why airplanes use kerosene today, we need to travel back to the early days of aviation. When the Wright brothers made their historic flight in 1903, their aircraft used a gasoline-powered engine. For decades afterward, most airplanes ran on gasoline because early aircraft used piston engines, which worked much like the engines found in cars. Fuel mixed with air inside cylinders, small explosions occurred, and those explosions turned a propeller. It was a simple system, and gasoline worked perfectly well for it. Even today, many small propeller aircraft still use a special type of gasoline known as aviation gasoline. So if gasoline worked so well, why did large aircraft switch to kerosene? The answer arrived with the invention of the jet engine. Unlike a car engine, a jet engine continuously pulls in air, compresses it, mixes it with fuel, and burns it in a powerful stream of fire. This creates the thrust needed to push an aircraft through the sky. But here's where things get interesting. When engineers began developing jet engines, they discovered that gasoline had a serious weakness, and the problem wasn't the engine, it was the sky itself. Modern airliners cruise at around 35,000 feet above the Earth. Up there, air pressure is much lower, and temperatures can drop below -50 degrees Celsius. These extreme conditions create challenges for fuel. Gasoline is highly volatile, meaning it evaporates very easily. At high altitudes, this can create fuel vapors that make fuel systems less predictable. Engineers wanted something more stable. Kerosene turned out to be the perfect solution. Because it is heavier and less volatile than gasoline, kerosene remains much more stable during flight. It flows reliably through fuel systems and performs consistently during long journeys through freezing skies. But stability wasn't the only advantage. There was another reason airlines chose kerosene. Imagine two fuel tanks that are exactly the same size. One can store more usable energy than the other. Which would you choose for a flight across an ocean? The answer is obvious. Kerosene contains more energy per gallon than gasoline. That means an aircraft can carry more flight power without increasing the size of its fuel tanks. For aviation, this is a massive advantage. More energy means longer range. Longer range means fewer fuel stops. And fewer fuel stops make modern international travel possible. But the real surprise is still ahead. Most people assume gasoline is safer because it's familiar. In reality, gasoline produces flammable vapors very easily. A small spark around spilled gasoline can quickly become dangerous. Kerosene behaves differently. It has a higher flash point, meaning it is much harder to ignite accidentally. This makes fueling operations safer for airports, crews, and passengers. Yet inside a jet engine, kerosene becomes incredibly powerful. When it is sprayed into the engine as a fine mist and mixed with compressed air, it burns efficiently and produces the enormous thrust needed to lift hundreds of tons into the sky. In other words, kerosene offers something engineers love. It is stable when safety matters and powerful when performance matters. And that's exactly why it became the fuel of choice for modern aviation. So the next time you sit by an airplane window and watch the clouds drift below, remember the surprising fuel making that journey possible. A fuel once known for lighting lamps now powers giant aircraft across continents and oceans. What seems like an ordinary liquid is actually one of the hidden technologies that quietly connects our modern world every day.